Morning class. As you can see on the board, the next topic is equations of motion. I can say that this topic is a very important in mechanics, or we can say it's basically essence of mechanics. Without these equations, so many concepts of mechanics is impossible. These equations are basically used to find the velocity, the acceleration or the distance covered by the body in certain interval of time. But the only limitation of these equation is we can use these equation only when the body is moving with uniform acceleration. That means A must be constant. If any body is moving with increasing or decreasing acceleration, that means a uniform that the acceleration is not uniform, it is non-uniform, then we can't apply these equations. For example, if you talk about the gravitation motion, in gravitation the force between two bodies is given by F equals to G m1 m2 upon r squared. That means the force depends upon the distance. So if distance decreases, force increases. If force increases, acceleration increases. So in that case, we can't apply these equation. But suppose an apple is falling from a tree, then it is acted upon by a constant force, the force of gravity, and due to that force, the acceleration acting on that apple is also constant. So we can apply these equations in such kind of examples. What are these equations? Equations, we have three equations of motion. First equation is V equals to U plus AT. In vector form, we can apply this arrow on the velocity and acceleration because these are the vector quantities. This equation relates the velocity and the acceleration of the body. The second equation is S equals to ut plus half at square. What is S here? S is displacement, A is acceleration, right? So this equation relates the displacement and acceleration. And the third equation is V square equals to U square plus 2AS. This equation relates the velocity, displacement and acceleration. So these are the three equations of motion, right? What are these symbols, or we can say letters, representing here? So U is initial velocity. V is final velocity. S displacement covered by the body. A is obviously acceleration. And you all know what is T here. T is basically time interval. So these are the letters in this equation. These represents U is initial velocity, V final velocity, S displacement, A acceleration and T time interval. Now you can see I have made a graph on the board. Why I made the graph? I made the graph so that we can find these equations. That means I know the equation as these are the equation, but from where we get these equations? right? So we get this equation with the help of graph. If you remember in the previous video, the graphs, so we can calculate the values of velocity, displacement and acceleration with the help of displacement time graph, the velocity time graph and the acceleration time graph. So by using, and I also made a table which represents the how we can calculate the velocity with the help of displacement time graph, how we can calculate the acceleration with the help of velocity time graph, right? So by using that table, we find these equations. Now the question arises, why I make the velocity time graph, why not the acceleration time graph or the displacement time graph? The reason is VT graph is special because by this graph we can find the displacement as well as acceleration, right? If we talk about the displacement time graph, we can just find the value of velocity but we can't find the acceleration. And in the case of acceleration time graph, we can just find the value of velocity but not displacement. But in this case, in VT graph, we can find the acceleration as well as displacement. So that is why we calculate these equations with the help of velocity time graph. So let's see the derivation. Let us find the first equation of motion. In this equation, we see that it is the combination of velocity and acceleration. Now, what was the acceleration? Acceleration A was slope. So here if we can find the slope of graph line AB, A will be slope of line AB, right? That will be the acceleration. Now slope of AB, A equals to slope of AB is, you can see that it is EB upon this AE, right? EB can be written as AC, right, on the y-axis, upon AE can be written as OD. Now what will the value of AC? AC can be written as OC minus OA, right, because we want this part. So if we subtract from this part from the whole OC, we'll get this part. So AC will be OC minus OA divided by OD. Now what is OC? OC is V minus, what is OA? OA is U upon OD is time T. So A we get V minus U by T. Or simply AT equals to V minus U, or simply V so you can see that we have derived the value of first expression, that is V equals to U plus AT. Let's calculate the second equation. Let's find the next equation, which is S equals to UT plus half AT square, right? Now here we have to calculate displacement or distance. Now distance or displacement from the VT graph is nothing but the area under the graph, right? So S will be area of OABD. This is the complete area under the graph. So OABD. Now you can see that this area OABD can be divided into two parts. First, the area OAED, rectangular part, and the area ABED, triangular part. So this can be written as area of rectangle OAED plus area of triangle, that is ABE. I'm writing plus here, plus area of triangle ABE, right? Just find what is the area of rectangle. That will be length and breadth. So that will be OA into OD, OA into OD, plus area of triangle, that is half base into height. So half base. Base is nothing but OD. See, we can see that here AE is equals to OD. What is height? Height is EB, and EB is nothing but it is equals to AC. What is OA? OA is U. What is OD? OD is T, plus half. What is OD? OD is again T. And AC is this. AC can be again written as OC minus OA. In the previous case, we have write the value of AC. Here AC can be written as OC minus OA, right? That is nothing but OC. OC is V and OA is U. We have all done this in the first equation. So this will become UT plus half T into V minus U, because OC, you can see that OC is V and the OA is U. And from the first equation, V minus U was what? Let's say this equation is 1. We know that V minus V equals to U plus AT, or V minus U equals to AT. So from this equation, we can write the value of V minus U here, and that will be AT. So using the equation number 1 and 2, what we'll get? We'll get S equals to UT plus half AT square. So this is your second equation. Let's find the third and last equation of motion, which is V square equals to U square plus 2AS. Right, again, the distance S can be written as the area of trapezium, the area of trapezium OABD. Now, in previous case, we have divided this trapezium into two parts, the rectangle and triangle. But if you know, we also have the formula for the area of trapezium, and that is the equals to half in bracket sum of the paddle side into the height of trapezium. Right? Let's quickly see what I'm saying here. Suppose this is your trapezium, right? Let's say this is A, B, C and D. So see, AD is basically height of the trapezium, and these two, AB and DC, these are the two paddle side of the trapezium. The formula of the area of trapezium is half sum of the paddle side, that means AB, plus DC, and into the height of the trapezium, that is nothing but AD. Right? So you can see here, similar concept we have here. We can directly apply the formula of the trapezium. So that will be half sum of the paddle side. Sum of the paddle side will be OA plus DB. OA plus DB into the height of the trapezium. That will be nothing but OD. Right? Okay. Write the values. So half, what is the value of OA? OA is U, plus what is the value of DB? DB is equals to OC, that is nothing but V, and OD is T. Let's say this is equation number 1. For the first equation, we know that V equals to U plus AT, right? Or we can write this equation as AT equals to V minus U, or T equals to V minus U upon A, right? So this is equation number 2. Write the value of time in the equation number 1. What we get? We get S equals to half U plus V and bracket V minus U upon A. Okay. So from here A can be come outside. This will become S equals to 1 by twice of A. Now this is we can write this equation as V plus U and V minus U, and you know that this becomes the formula of A plus B and A minus B, which is A square minus B square. So this term will become, this will come here, cross multiplication, so 2AS equals to V square minus U square. You can send this U square on the left hand side, so this becomes V square equals to U square plus 2AS. So this is the third equation of the motion. So this is how we can calculate, we can derive the equation from the graph. Now you understood why the graphical representation is so important, right? So if you don't know how to deal with the graph, you can find these equations. If any body is falling freely from some height, then these equation will become V equals to U plus GT, H equals to UT plus half GT square, and V square equals to U square plus 2GH. So in the place of A, we replace A by G and the S by H, right? So these are the equations we can apply when the body is freely from the height. One more important thing, if body is moving upwards, that means against gravity, like this, then G will be taken as negative. Okay? And if the body is coming downwards, then G will be positive. So please keep this in your mind while you're solving the numerical. So we have done this chapter. In the next video, I will do some numerical on this chapter. Thank you so much, class.